Teach Pokemon to understand. 9.2 Arithmetic Sequence. We're starting a new chapter on sequences and series. Let's see what sequences do. Arithmetic sequence. Here's the definition. An arithmetic sequence is a sequence in which one term equals a constant, either added or subtracted to the preceding term. All right, let's see what this means. A sequence is just a pattern, like this list of numbers that follow a very specific pattern. 3, 10, 17, 24, 31, 38. Do you guys recognize the pattern? It's a pretty obvious one. You're basically adding 7 every time. So when you're adding a constant number every single time, that is called an arithmetic sequence, adding or subtracting. Question from your homework. Find the next term. Super easy. Just add 7 to the 38. There it is, 45. What if I asked you to find the next 3 terms? Still pretty easy. Add 7 to 45. We get 52, and then 59, and then 66. It's just adding. Very simple. All right, but what happens when I ask you for the 100th term? All right, so you have to go and list out all 100 terms to figure out what that is. That's kind of tough, and it's going to take a long time. And if you miss add by just a little bit, you're going to get the wrong answer. All right, so there's got to be a shorter, better way to do it. I can tell you the answer right now. It is 996. And yes, you can continually add 7 until you get to the 100th term, but that's a lot of work. So we have a mathematical way of doing it. There's a formula. AN is equal to A1 plus the quantity of n minus 1 times D. Let's figure out what all of those stand for. A1 is the very first term. In this case, it is 3. It's the first term. It's important. The n is how many number of terms there are. So in this case, if I'm asking for the 100th term, the 100 would go there. The D is called the common difference. That's the number that you either subtract or add every single time. In this case, the common difference was 7. You're adding 7 every single time. And then AN is just the nth term, what term you were looking for. In this case, we were looking for A sub 100. So plugging everything in, see that 100th term, it matches this n over here. The 3 was the first term, and then the 7 is the common difference. Use PEMDAS, basic algebra skills, to get the answer. A100 is equal to 696. All right, let's do another example. 25, 22, 19, 16, 13. The question is this an arithmetic sequence? Well, is there a number that you add or subtract consistently to get to the next number? And the answer is yes. What is that number? What's the common difference that you're adding or subtracting? It's actually -3. You're subtracting 3 every single time. And so make sure you put -3 because that's important. Let's go ahead and write a general formula for this sequence. Here's the equation, the formula that I gave you guys. Let's fill in everything we know. We don't know what we're asked for. We don't know what term they're asking for, but we do know the first term, and we do know the common difference. So let's plug those in. There it is. That is the general formula. You can simplify that a little bit by distributing the -3 into the parentheses and cleaning it up. And there we have it. AN is equal to -3n plus 28. From there, you can get any term you want. So let's go ahead and find the 100th term by plugging in 100 into the n. And that's all you get. Simplify it a little bit. The 100th term is going to be negative 272. All right, let's do a tricky one. This one's tricky because obviously it has fractions, and fractions are kind of tough. Is this an arithmetic sequence? What are you adding or subtracting to get to the next number? It is an arithmetic sequence. The difference, the number you're adding in this case is 1/4. If you're good at fractions, you can see that if you add 0 to what if you add 0 with 1/4, you get 1/4, and if you add 1/4 to 1/4, you get 1/2. So you keep on adding 1/4 every single time. Now, if you're not good with fractions, then there is actually an easy way to do this. You just take the number in the front and subtract the number behind it, and you should get 1/4. And then just keep doing that. Take the number in the front, subtract the number behind it, you should get 1/4. Subtract the number behind it, you should get 1/4. All right. Subtract the number behind it, you should get 1/4. All right, so that's an easy way to do it. Let's write the general formula. Again, we know the first term and we know the common difference. So there it is. Simplify that a little bit. There's the general equation. That equation will let you figure out whatever term you're looking for. So let's go ahead, in this case, find the 20th term by plugging 20 into the n. Do a little bit of math, and you should get 19/4. Remember, go back to the 6th grade, figure out how to add and subtract fractions. You have to get the same denominator. So that's a good review from the 6th grade. Arithmetic mean. This right here is just notation. It's just a way of saying, here's a bunch of numbers, dot, dot, dot. Here's one of the numbers. Here's the number before it, n minus 1. And here's the number after it, n plus 1. So when you see something like that in the directions of the homework, that just means there's a sequence of numbers. Like for this one, let's say I give you dot, dot, dot. So there's a whole bunch of numbers before, a whole bunch of numbers after, and then somewhere in the middle, you have those 3 numbers. How do you find that middle number? It's pretty easy. You just go ahead and take the average, add them together, and divide by 2. There it is. There you go. This one's a little bit more tricky because it has 3 missing numbers in the middle. And you can do the same thing. You can take the average and then find this middle one, and then take the average of these 2 and find the middle one, and then take the average of these 2 and find the middle one. But there is actually another way to do it using the same formula, and then fill everything in that you know. We're going to consider this the last term, the 52. The first term is right here for the A1. The n, remember, has to match with this n. And so it's asking what place is the 52 in, and if you count, this is 1, 2, 3, 4. So the 52 is in the 5th place, and that's why there's a 5 there. And then from here, you have a pretty simple Algebra 1 problem to solve. Solve for D, use PEMDAS. You should get the D equals 7. Once you have 7, you just go ahead and add 7 to all the numbers. 24 plus 7, 31 plus 7, 38 plus 7, and then just to check yourself, what is 45 plus 7? It is 52. All right, so that's how you do those. Here's another one. This one's has 2 missing terms in it. There's the formula. Remember, the last term is 102. The first term is 123. This fourth term, well, the 102 is the 4th term in the sequence, and that's why the n is 4. Use a little bit of algebra. You get -7 in this case, so subtract 7, and then just to check yourself, subtract 7 one more time to see if you get 102. Going backwards, the last one for the day. The number 68 is a term in the arithmetic sequence with A1 equal 5 and D equals 3. Which term is this? So basically, there's a whole bunch of numbers, dot, 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 and then somewhere along the lines, there is a 68. That's what that number is. And then they say the first term is 5, and then the common difference is 3, so the next one is 8, the next one is 11, but they want to know how far do you have to go down to get to that 68. Easy stuff. We're just going to use the same formula we've been using. There it is. Let me clean this up a little bit. Let's plug everything in that we know. We know the term that we got is 68. We know the first term is 5, and we know the common difference is 3, and we're looking for n. And then again, use your algebra skills, solve it out. N equals 22. So it looks like you have to go 22 terms down to finally get to 68. All right? These are kind of fun. Go ahead and try your homework now.